Hello everyone. Today we're going to be working on section 4.3, which is the real zeros of a polynomial function. Next section we'll be working on all zeros of a polynomial function, but for 4.3 we're only looking at ones that are real numbers. So we're going to be working today on all of the things needed in order to find zeros of a function and factor a function. So the first thing we need is called the division algorithm. And it basically says that if you have a function f of x, then you can, and it's a polynomial, then you can find a function d of x, and that's the divisor function, and you've multiplied that by q of x, or the quotient, and add r of x, or the remainder, to it in order to get the original function. So r of x is the remainder, d of x is our divisor, q of x is our quotient. If r of x is equal to 0, then that means the function d of x, the divider, divides evenly into our function f of x. And we're going to go through and practice some division today. So I want to start with what's called long division of polynomials. Now, long division of polynomials is very similar to long division of regular numbers. So here we want to divide f of x is equal to 2x cubed minus 5x squared minus 6x plus 9 by x minus 3. To give us an idea of what we are achieving as far as division is concerned, I'm also going to work a problem with actual number division over here to the side. So let's say we wanted to divide 782 by 4. So if we were dividing 782 by 4, we would put the 4 on the outside and 782 on the inside of this symbol, and then we would go through and divide. Now, same thing is true if we're using polynomials. So we want to divide 2x cubed minus 5x squared minus 6x plus 9 by x minus 3. So I'm going to take the 2x cubed minus 5x squared minus 6x plus 9, and I'm going to put it inside the symbol and put x minus 3 on the outside. Now, when we go to divide numbers, we're going to take this 4 and see if it goes into 7. So 4 goes into 7 one time, so I'm putting a 1 on the top. Now, same thing is true with polynomials, except we're only going to be considering this first number here. So the first digit here is x, so I want to know if x goes into 2x cubed. Now with polynomials, it's a little bit more difficult to visualize, so if you have not done polynomial division before, what you can do is on the side you can write those two terms over each other and then cancel things out to see how it divides in. So for example, 2x cubed divided by x, I cancel one of my x's and I get 2x squared. So that's how many times this x goes into 2x cubed. So I have 2x squared on the top. And then if we look back at our numbers, what we do from here is we multiply. So 1 times 4 and we get 4 here. Same thing is true in the polynomial side, so now I'm going to multiply. So 2x cubed times x gives me 2x, or 2x squared times x gives me 2x cubed. Now the polynomial has two different terms, so I have to multiply both. It's like distribution. So 2x squared times negative 3 gives me minus 6x squared. On the number side, what we would do then is we would subtract. So I'm going to draw a line under, and we are going to subtract the 4 from the 7. So solution gives me 3. Then once I have the 3, I'm dropping down this 8 here. All right, over on the polynomial side, same process except we're dealing with x's. So I'm going to subtract this whole term here. Now this is the piece that I'm subtracting, so if we are looking at this, we're going to distribute this negative sign, and it's going to turn this 6x squared positive. So 2x cubed minus 2x cubed gives us 0. Negative 5x squared plus 6x squared gives me just plain old x squared here. and then we're going to drop the next term down, so minus 6x. All right, back over to our number side. Now I'm trying to determine if 4 goes into 38. So 4 goes into 38 9 times, and then same process again. 9 times 4 gives me 36, and then we're subtracting, so I end up with 2, and we drop our number down. Now, if I'm looking on the polynomial side, I'm considering x going into x squared this time. So remember that if you can't visualize it, and you'll get to the point where you can, but if you can't visualize it, you can write your factors over to the side. So x going into x squared cancels an x, and we end up with x. Our sign is positive, so I'm going to write plus x up here, and then we're going to multiply. So x times x gives me x squared. X times negative 3 minus 3x, and then we are going to subtract. So I'm subtracting the whole thing, meaning that I'm going to have to distribute and change this sign. So once we subtract, x squared minus x squared gives me 0. Negative 6x plus 3x gives me negative 3x, and we're dropping down the 9. All right, over on the number side, 4 goes into 22 5 times. So we multiply, we have 20, and we're left with 2. On the polynomial side, x goes into negative 3x. Negative 3x over x. My x's cancel, and I get negative 3. So negative 3 up here on the top, and then we're going to multiply. So negative 3 times x gives me negative 3x. Negative 3 times negative 3 gives me plus 9. And then we're subtracting. Oop, that's pink, not red. Here we go. So my signs both change, and I end up with 0 here. Now you notice that we have a polynomial up here on the top, and that is our quotient. So we have our divisor over here, the x minus 3, our quotient on the top, and if we had had anything here other than 0, that part would be our remainder. So far, f of x, according to the division algorithm, is equal to x minus 3, the divisor, times the quotient, 2x squared plus x minus 3, and plus the remainder, or r of x, but that's equal to 0 here. Now this also says to use the result to factor the polynomial completely, so I'm going to factor this part. So we have x minus 3. I know that it's going to factor into 2x and x. I also know that it's going to be a plus and minus sign. Now the arrangement of that, I need positive x in the middle, so I am going to do plus 3 and minus 1. So 2x plus 3 times x minus 1 are the factors of that one. If you need to check the middle term, 2x times x gives me 2x squared, middle term, minus 2x plus 3x gives me positive x, and then negative 3 for the last one. So here is my fully factored form of this polynomial. If I want to divide f of x is equal to negative x cubed plus 4 by x minus, or x plus 2, same process. I'm not going to do the number side this time, but I am going to put x plus 2 on the outside, and on the inside I have negative x cubed. And here is one thing that's different. Now this is negative x cubed plus 4, but we don't have any x squareds, we don't have any x's. Anytime you are missing terms, if you're going in descending order by power, you have to add them. So I have plus 0 x squared plus 0x plus 4. I'm not actually adding anything, but these are placekeepers in order to make sure that my, my factors come out correctly. All right, so x goes into negative x cubed. I'm going to end up with a negative sign. If I were to put those one on top of the other, x would cancel, so negative x squared. Multiplying, negative x cubed minus 2x squared, and then we're subtracting. changes the sign for both of them. So I have 0 and I have 2x squared, bringing down plus 0x. X goes into 2x squared. I have positive 2x times. So 2x times x gives me 2x squared. 2x times 2 plus 4x, and then subtract. All right, so negative 2x squared gives me 0. This one turns negative as well, so we have minus 4x, bringing down the 4. X goes into negative 4x minus 4, so negative 4x. And here we have negative 4 times positive 2 gives me minus 8. Subtracting turns positive, so here we have negative 4x and gives me 0, and I end up with positive 12 for my remainder. So this is a remainder, and typically we put the remainder over whatever we're using as the divisor. So f of x here would be equal to x plus 2 times negative x squared plus 2x minus 4 plus 12 over x plus 2. And there's our result. This last part is our r of x, or our remainder part. Now there is a different form of polynomial division called synthetic division. If you are dividing by just something like x minus k, not something like 2x minus 3, so it has to be just a single x that you're dividing by, you can use what's called synthetic division. And for synthetic division, essentially what we're doing is we're dropping all the x's and just using the coefficients for each number. It is a pattern, so we'll go through and practice this pattern, but this is exactly what happens. So you take the coefficient of your dividend, and you end up with the coefficient of your quotient and your remainder, if any. So if I want to use synthetic division to divide f of x is equal to x cubed minus 2x squared minus 9x plus 18, and I'm dividing by x minus 2, then how I'm setting this up, x cubed has a coefficient of 1, negative 2x squared, coefficient of negative 2, negative 9x, negative 9, and positive 18. Now when you look at this picture, they actually have a big bar, but traditionally what we actually see most is a little box that you put your divisor in. And this divisor is x minus k. So if you have a negative sign in here, all you're doing is putting that number k. All right, so the algorithm part, first thing we do is drop the first number. So we drop it down just like this, and then we multiply. So 2 times 1 gives me 2. And then we add the next column together. So negative 2 and 2 gives me 0. And then multiplying, 2 times 0 gives me 0. Negative 9 and 0 gives me negative 9. And then we multiply again. I have negative 18, and 0 is my remainder. So if I have a 0 here, then it is a factor of our original function. This part here is our quotient. So if we started with a cubic function, then whatever is left here is one step down from that. So I would be left with x squared, or 1x squared, plus 0x minus 9 here. So far my function f of x is equal to x minus 2, that's the factor we were dividing out, times x squared minus 9, and we can factor that further into x minus 2, x minus 3, times x plus 3. The remainder theorem actually says that if you divide a function by x minus k and you get a remainder, then that remainder is what you would have gotten if you plugged k into the function. So if I want to find f of 5, I can divide out 5 in this function f of x and see what I get. So this is a cubic function. We're dividing out 5, and my coefficients are 2. Now I don't have a squared term, so I actually have a 0, -3, and 4. So if we drop down our first number, then multiply, so 5 times 2 gives me 10. Adding it, 10, 50, 47, 5 times 47, handy calculator, 235, gives me a total of 239. Now if I were to plug 5 into this, f of 5 is equal to 2 times 5 cubed minus 3 times 5 plus 4. 5 cubed is 125, so we have 250 minus 15 plus 4, not 5. 215 minus 11 gives me 239. Result is the same both ways. A lot of times your arithmetic is nicer if you're using the division algorithm, or if your polynomial is very large. The factor theorem says that a function has a factor of k if f of k is equal to 0. So if you plug in your number k into the function and you get 0 back, you know that it should divide out. So if I want to test whether x minus 2 is a factor of f of x before I go to divide it out, then I can plug in 2 to see. So f of 2 is equal to 2 times 2 cubed minus 3 times 2 plus 4. 2 cubed is 8, so 16 minus 3 times 2 is 6 plus 4. 10 plus 4 gives me 14, not a factor. Now remember that it also says that the remainder is f of that number. So if I were to then divide it out, I have 2, 0, -3, and 4. Dropping down the 2, 2 times 2 gives me 4, still 4, 8, 5, 10, 14. So there is my f of 2. The two things are very related. So if you're looking for the function at a value, you can find it this way, or you can figure out if something's a factor that way. All right, so say that I'm given that x plus 5 and x minus 4 are factors of this 4th degree polynomial. And I want to find the remaining factors. The first thing I want to do is divide out these two factors to see what I'm left with. So if we're dividing out x plus 5, the number I'm putting in the box is -5, because remember we have x minus k. All right, so my coefficients, 4, -81, -1, and 20. Dropping down the 4, -20. I have -16. All right, 5 times 16 gives me 80, and it's positive because they're both negative. So I end up with -1. 5, end up with 4, -20, end up with 0. Okay, 0 means that it is a factor. So far for my factored form, remember this is down by 1 degree. So we started with a 4th degree, so this is x cubed, x squared, x, and 4. So far I have x plus 5 times 4x cubed minus 16x squared minus x plus 4. Okay, I also know that x minus 4 is a factor. Now, when I go to divide that out, I'm not going to start with the original. I'm going to start with this reduced polynomial when I go to divide out the 4. So I have 4, and my coefficients are 4, -16, -1 and 4. 16 gives me 0. 0 gives me -1. And -4 gives me 0. So remember, now we're starting with a cubic function, so this is a second degree. So we have 4x squared minus 1 because we have no x's. So now at this point f of x is equal to x plus 5 times x minus 4 times 4x squared minus 1. And this last piece is a difference of squares. So x plus 5, x minus 4, 2x plus 1, and 2x minus 1. And there's the rest of my factors. All right, a couple other things that'll be helpful when you're doing your homework for this section is the rational zeros test. So if you have a polynomial function that's a(n) x to the n all the way down to a sub 0, a0, all the rational zeros of that polynomial function are a ratio of p over q, where p is a factor of the constant coefficient, so the 1 at the end, and q is a factor of the first coefficient, or the coefficient on the highest number. So if, for example, f of x is equal to 3x squared plus 2x minus 1, then this is my constant. So we have our constant is equal to p here, and our q is the first coefficient, so q is equal to 3. When we put those together, the first one, factors of that are going to be on the bottom. So when we're talking about factors of a number, 1 is always a factor of a number. So the factors of p in this case would be positive and -1, and the factors of q, we can get 3 by doing 1 times 3 or by 3 times 1, so we would have positive and -1 and positive and -3. So as far as when we put together all the possible zeros you could have, rational zeros you could have, possible options include all combinations of these numbers. So I could have, for example, 1 over 1. So that results in positive and -1, 1 over 1. But I could also have the fractional component, so I could end up with 1 over 3. So both positive and negative 1 over 3. Be careful when you're doing this homework. Sometimes they require that you put these in numerical order. So if I were going to put these in numerical order, the numerical order would be -1 because it's the lowest, then -1/3 because it's closest to 0 on the negative side, then +1/3. I wouldn't put in the positive side, but the 1/3. And then +1 would be your highest, if you have to list them from least to greatest. All right, if I want to find all the zeros of some functions just starting fresh, the rational zeros theorem actually allows me to narrow down my possible options. So if the leading coefficient is 1, then all of my rational zeros for this function are going to be whole numbers that are factors of 12. So my possible options, plus and minus 1, plus and minus 2, 3, 4, 6, and 12. Now I know that seems like a lot of possible zeros, but usually you find one pretty quickly. So the first one I'm going to check is 1. And using synthetic division, I'm going to bring that down. 1 times 1 is 1. -4, -4, -5, 5, 19, 19. I don't really need to know what the remainder is, but if it's not 0, it's not a factor. So let's try -1. Now I'm not using these numbers because I struck out there. So 1, -5, -1, 17, and 12. Dropping down the 1, -1 gives me -6. 6 gives me 5. -5 gives me 12. -12 gives me 0. All right, so -1 is a factor. So far g of x is equal to x plus 1 times x cubed minus 6x plus, or x squared plus 5x plus 12. Now, if I had reduced my 12 here, then all of the rest of them would have been factors of that reduced number. I haven't reduced that 12, so I'm going to move on to the next number here and try 2. So 1, -6, 5, and 12. Dropping down 1. And -12 and 0. All right, so 2 is also a factor. And we have g of x equal to x plus 1 times x minus 2. And then our reduced polynomial, now we're squared. So x squared minus 4x minus 3. Once you get down to a quadratic, you can factor this with regular methods. So you don't have to continue synthetic division, you just factor it. So g of x is equal to x plus 1 times x minus 2 times x. We have a negative and a positive, and we have x minus 3, and hold on. 3 and 1 give me 4. They're both negative though, negative, and does not factor. All right, if you want to make sure that you have something that doesn't factor, you can use the quadratic formula. So x is equal to -b, so 4, plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is -3, all over 2 times a. 4 plus and minus the square root. 16 plus 12 gives me 28 over 2. And simplifying, square root of 28 doesn't simplify, but it is 4 times 7. So this is 4 plus and minus 2 square root of 7 over 2. I can cancel a 2 throughout, simplifying it into 2 plus and minus the square root of 7. All right, so now if we're going through and finding all of the factors in factored form, g of x is equal to, actually we just started it, so we'll write it up there. G of x is equal to x plus 1 times x minus 2, and we have x minus 2 plus the square root of 7, and x minus 2 minus the square root of 7. And those are all our factors. All right, let's try that one twice more, actually. So if I'm looking at this next one, f of x is equal to 2x cubed plus x squared minus 10x minus 5. Here is my p over q. We're working with 2 and -5 this time. So my possible options, if we're working with -5, here the factors are 1 and 5. Always positive and negative. 2, 1 and 2. Positive and negative. So all combinations of that mean that I have positive and negative 1 over 1, which gives me 1. Positive and negative 1 over 2. Positive and negative 1 over 5. I'm sorry, 5. and 5 over 2. This number goes on the top. So those are all of my possible rational zeros. One of them will likely be one of these halves. So I want to start with those just because I don't want you to be intimidated by trying to divide out fractions. So let's start with 1/2. And we have 2, 1, -10, and -5. So I'm dropping down the 2. 1/2 times 2 gives me 1. So we have 2. 1/2 times 2 gives me 1. I have -9. 1/2 times -9 gives me -9/2, which is not 5, so that doesn't work. So trying -1/2, 2, 1, -10, and -5. Dropping down the 2, 2 times -1/2, -1 gives me 0. And -10. -10 times 1/2 gives me 5. And we have a 0. So here, so far, we have a winner. So far, f of x is equal to x plus 1/2 times 2x squared minus 10. Now, anytime we divide out a half like this, it doesn't look like normal. So I also noticed that this has an even, both of these terms are even, so I can pull a 2 out of it. So for convention, we can take this, pull the 2 out of here, we get x plus 1/2 times x squared minus 5, and I can multiply that 2 into my first term just to get rid of that fractional component. So here I have 2x plus 1. X squared minus 5, difference of squares, just not nice ones, so x minus the square root of 5 times x plus the square root of 5. All right, last one. I have 2x cubed plus 11x squared minus 7x plus 6. So 6 is my last term, 2 is my first term. Factors of 2 are 1 and 2. Factors of 6, 1, 2, 3, and 6. So we have a lot of options for this one. Remember, top, bottom. So my possible options, plus and minus 1, plus and minus 2, 3, 6, 1/2. 2 halves gives me 1. 3 halves is a new one. 6 halves gives me 3. So those are my factors. Looking at these, let's try 1 first. So if we look at 1, 2, 11, -7, and -6. Dropping it down, 13, and positive 6, and 6 and 0. Wow, 1 was right. All right, continuing on. So we have f of x here as x minus 1 and 2x squared plus 13x plus 6. All right. If I want to try and factor this, I can use the, there's what's called the AC method for factoring. If you are looking for factoring practice, coolmath.com has a bunch of factoring practice. But if I want to factor this, if I multiply my A term and my C term together, it gives me 12 positive, and I have a 13 for my middle term. So I'm looking for two things that multiply together to give me 12, add together to give me 13. They're both positive, so it looks like 3 and 4. Multiply to give me 12, and then 12 and 1 actually add together to give me 13, because 3 and 4 do not add to 13, but 12 and 1 do. So what I do is I take that and I put it over my first term and then reduce my fractions. So 12 over 2 reduces to 6 over 1. and 1/2 is already reduced. To put these into the actual factored form, the number on the bottom goes in front of the x. So 1 gives me x, the number in the back, or the top goes in the back. So x plus 6, and this would be 2x plus 1, and that's what that factors into. All right, so f of x equal to x minus 1 times x plus 6 times 2x plus 1. Now, if I wanted to know what the zeros were, each one of these set equal to 0 is a 0. So x minus 1 equals 0 gives me x is equal to 1. X plus 6 equals 0 gives me x is equal to negative 6. And 2x plus 1 equals 0 gives me x is equal to negative 1/2. All right, if you have any questions, reach out, and good luck on this section of homework. Have a good day.